Let's just try that again. Clean off. File. At some point I should really get that dependency tracking stuff to work. So we're linking CXX executable longshot, and we're done linking. So let's try reloading that. Invalid version directive. Fair enough. Version 300 ES. So we're going to try and write ES on caps. And then do that again. So we're linking, and we've linked. Let's reload. Still lots of interesting errors. No precision specified. Varying, invalid use of reserved word. So apparently I need to give a precision on a sampler. I guess. No precision specified. Sampler on line 3. So we're going to go for a uniform, low precision sampler 2D. Can always play around it. We need to increase the precision at some point. But for now, low precision sounds great. We're linking. And we've linked. Let's try and reload. Varying in illegal use of reserved word. I would have expected this to be legal, but apparently not. Oh, and apart from that, I can see I need to use a sampler 2D array, probably. Is there also a texture 2D array to look them up? Built-in functions, built-in functions. No, they're just called texture now. Fair enough. So build-ins for vertexes, constant, uniform, state, parameters and functions for qualification. Integration. So this looks like a question for Google. OpenGL, GL, ES, GLSL, 300 ES, varying. How to update a shader. It's great for iOS, but So change qualify varying. GLS, the varying qualifier uses variables that hold data that is output by vertex shader for each vertex. This can be definition of varying in the vertex shader, like this. So if it goes from varying to becoming in. Fair enough. That probably makes it a little bit more uniform with stuff like compute shaders and stuff like that. So these are just in. It's going to be interesting to see if it can link a 1.0 vertex shader with a 3.0 fragment shader. That's going to be fun. And I think this is just texture, and this is sampler to the array now. So let's try and clean up and compile again. There we go. Switch back over here and refresh. So GL frag color, it's not happy about that. So define the fragment color in GLS. There's a way. This variable does not exist in GLSL 3.8.0 anymore. We just have to output a fragment color. So I have an out, low precision vector 4 called GL frag color. And we'll try that again. It just has to be the only output, I guess. Don't really know how multiple render targets would work then, but we're not doing that, luckily, at least not yet. This is where it becomes really interesting. So we've compiled that. Gonna jump back here and refresh. So, GL reserved built-in name. So that's going to be called fragment color. And then we're going to use that instead. Like that. We're going to clean again. And compile. So with that linked, we can switch over and refresh. And what's the next problem? Yeah, Vertex Shader version 100 does not match Fragment Shader version 300. So we can't mix and match. So we're going to have to update the Vertex Shader as well. So where's my Vertex Shader? Here it's version 300 ES. So these uniforms are the same. These are, instead of attributes, they're in. So we pull in these three, and then we output these two. And we also need to output a GL position. Just gonna go over here because there was something here. Because there are some special variables here. I might say GL per vertex, GL position, maybe. I'm gonna want to just GL position. Nothing mentioned about GL position. I might be able to see that, might not. I'm not entirely sure. Well, easiest way to find out is by trying. So we are gonna clean and rebuild. And we are done. Let's refresh. Well, that seems to have at least done something. So there's a little bit here. WebGL warning, draw elements, active texture 0 for target is incomplete and will be rendered as RGBA whatever as per GLES. Because the minification filter requires MIP mapping, the texture must be MIP map complete. There we go. So I was kind of hoping, because the minification requires MIP mapping, I'm forgetting to set all of this stuff, which is of course unfortunate. So we want to do that to GL texture 2D. Let's just try that again. Because I'm trying to ask for no MIP map levels, but I might be interpreting GL text storage 3D wrong, and that this should be 0 layers of MIP maps. You never know. Let's try refreshing here. There we go. So we now have the stone texture rendering, because that's 0. That means that ideally, if, just to try it out, we go into the fragment shader and we use 2 instead, that should be grass. So we're going to try that. And with that linked, we just refresh. And everything is rendered as grass. Nice grass texture. So that's good. So now what we need to do is we need to actually be able to tell what is grass and what is not grass. And this is where it gets interesting, to say the least. Because that means that we have to sort of dig down into our terrain generation and into our chunk data structures. So we have some terrain generation somewhere here. So I'm setting 1 or 0. 0 is air, 1 is at the moment stone. And the idea here is to look at, we have this sort of, we have a base height map, and we use that to calculate a cutoff, and then we do some other weird stuff. So what I would like to do is, in the case where it's, so if y is less than height, we set something. So in this case, if y is less than height, what I'd like to do is I'd also like to say if y is less than height minus 2, we set it as stone. Otherwise, we're going to set it as dirt. We're going to call that 2 for now. And all of these lumps on top are always going to be dirt. Now we have both 1, 0, or 0, 1, and 2. So that means we have to take a look at our chunk renderer. Make sure it's not completely crazy. So what we're doing is we look at whether they are exactly 0. So if our current chunk is not 0 and so on, then we add faces. Now the thing is, we also need to have what we also need to do is we also need to somehow indicate what kind of block this is, so that the face actually knows that. Now the annoying thing here is that sort of annoying, is that we are reusing the same vertex buffer for a lot of things. For this, we can't do the same vertex buffer because we need to associate with the vertices which material they are, whether they're stone or dirt. And then we're going to have to make our decision based on that. Because we can't pass data directly to the fragment shader, we have to go through the vertex shader. So we need to put it on the vertexes, but we can't set the same for every single chunk. So every chunk has to have its own, essentially its own vertex data about what material it is. And that means we have to run through some edges and set that up so that when we use the correct index buffer, we also get the correct, we get the correct material on it as well. So what we're going to do is we're going to take a look at our chunk renderer here. First of all, we have a generate vertex buffer somewhere. Here, generate vertex buffer. That's going to be global vertex buffer now. And this vertex buffer here is also going to be global vertex buffer. And this is going to be global vertex buffer data, and this is going to be global vertex buffer initialized. And then we need to, of course, update everything over here. Generate global vertex buffer, generate index buffer, and so on. So we find our global vertex buffer here. And for our generate our global vertex buffer here. All of that is not to worry about, but we need to set this up. Like that. And then we generate the buffer here. We load it with data. So we have the idea of some vertex data over here, which is a structure, I believe. Yeah, that's going to be global vertex data now. There we go. Because what I'd like to do is I'd like to introduce, we're going to have another structure, which is going to be our local vertex data. And it's just going to have a glint called the material. And then we're going to have the offset to the material here. Because in addition to having an index buffer data and an index buffer, I want a local vertex buffer data and a local vertex buffer. And local vertex buffer. Great, and then we also have a generate local vertex buffer. So we get all of that stuff running. So yeah, now we're looking at the global vertex buffer data for the sizes here. Because what I'd like to do is, if our chunk version, I not only want to generate the index buffer, I also want to regenerate the local vertex buffer. And I also want to do that on the initialization up here. Generate global vertex buffer like that, and all of a sudden all those arrows disappear. And this is global vertex data. This is global vertex data, global vertex buffer, global vertex buffer. We also have a couple of these things where we have global vertex data, as in the type, and we have local vertex data, where we have the offset of the material, which is going to be the offset in the local vertex data of the field material. There we go. And this is, of course, in the global vertex data, not in the local vertex data anymore. Never used, that's fine. Let's see if that compiles. Shouldn't link. So to generate our local vertex buffer, so we have a chunk renderer, generate local vertex buffer. There we go. We're going to run the same loop here with the facing directions. Here, we don't want to do that. And I don't really care a lot about normals. But I will be doing a lot of stuff in, or some stuff in here. And we're going to generate one buffer into the local vertex buffer. And we're going to bind that with our local vertex buffer data. So the size times the size of an element of local vertex data. Then we're going to have local vertex data. And that's static draw. So what we want to do is we want to go for our local vertex buffer data here, and we're going to do this with a vertex index, indexing X, Y, Z, and facing. And what we're going to set here is that we are going to look up our chunk here. We want to, no suggestion, we want to get whatever is at X, Y, and Z and store that. So we get to store the material over there, and then we need to actually pass that in. And this is where it gets interesting because we don't actually have an attribute to work with. And in a sense, that shouldn't really be the biggest problem. But because of the way we're currently passing that in, I have to do a lot of changes to make that work. So what I'd like to do for the chunk renderer is, instead of also taking just the class, what it should also do is it should also take a const GLES material. Yeah, that's exactly the one. And this is going to be a reference to the material that it should render with. Yes, I want to import that. And then I actually want to store that material. So in our chunk renderer here, we are also going to store the material that we render with. And I don't need to actually include that. A forward declaration should be enough here, because it's just a reference. Expected semicolon at end of declaration, I can understand that. Now we also just need to change this so that we're past a const GL yes material. There we go. Now when we're constructing in our renderer all of this, we have access to the material. It's called mat. So we just initialize it with that, so we can pass that in along with it. And apparently that's supposed to render at this point, but that's because we haven't really done anything different. If we just, for the hell of it, switch over, we should see nothing. Well, I said nothing. We get an index out of bounds, which is always fun. So we're just quickly going to switch back here. Take a look at our renderer. That's because the local vertex buffer is a vector right now, and I actually want it to be an array of local vertex data, because this has a fixed size that I know beforehand. And I, of course, don't want to just do that. I want to say that the material is equal to that. So we link, we built, and now we shouldn't get an exception. We just get grass rendered. Great. So having done that, we have our vertex index here. Trying to think a little bit, that's hard. So we've done that, we've set that up. So what we want to do, we have our material available. We're going to kill off pretty much all of these because we don't need to pass them anymore because we have the material ourselves, and so does the skybox renderer. And because that's the only one that really should care about that. So that's great. So what we want to do is we have vertex attributes, so on and so forth, is that we find another buffer and set up another set of attributes. So what I'd like to find this time is the local vertex buffer. And then we're going to use something called material attribute, which doesn't exist yet. So this is, oh, sorry. So we're going to find the local vertex buffer here when we're rendering, and then we're going to use something called a material attribute to transfer the material to. So what we need to do is we want to look at vertex attrib pointer. Attrib pointer. Here we go. So index is the one we grab. Size is in, I don't know what. Based on the fact that we are currently saying 4, it's the number of elements. So it's one element. It is of type GL. I want to say GL unsigned int, but that requires that we just change the type in a moment. So it's unsigned int. It should not be normalized. Let's try it. I'm editing the wrong place. I want to add it down here. So 1 GL unsigned, not byte, but int, not normalized. The stride is the size of the local vertex data. And the offset of this is the local vertex data and the offset of the material. There we go. And for the material attribute, I'm going to do this up here. Auto material attribute. That is taking the material and calling get attribute, not vertex position, but material. So we're going to give this another attribute. Okay, yeah, GLES material here. So it has a lot of stuff already. So I want also to know about an attribute, possibly an attribute called material. It might exist, it might not. It doesn't necessarily have to. So get attribute material. So get attribute material. And the attribute is not the vertex texture. It is the attribute material. There we go. And it looks for something called material over in the shader program. So we also want to just say that attribute material is initialized to -1. There we go. I need a semicolon here. I'm linking the C++ executable, and we've built the target. So that's good. So for our base here, we also have an input. No precision on that, but it's an integer called the varying material. That's the varying. We have to patch that through the vertex shader. And what I want to do is I want to grab the varying material +1, no, -1, and use that to look up the texture. So we've got that. Great. So what we can do here then is look at the vertex shader, because I want to output an integer called varying material, and I want to pull in an integer just called material. And just like we just passed through the texture coordinates, we also just passed through the material. Like that. And let's try and clean this and run it. Just waiting for it to finish building. We're linking. And we've linked. So if we refresh, we're getting lots and lots of interesting warnings here. Out must use flat interpolation here. Yeah, I was kind of expecting that. So it can't really interpolate an integer. So we have to say it's flat instead. So that it doesn't try to interpolate. It just sort of continues the vertex attribute along the entire surface. So the question is, how do you specify that it's flat? It's I may proceed in, centroid in, out, or centroid out. So it's smooth or flat. And let's see, there was something about the order. Invariant, interpolation, storage precision, or storage parameter precision. So it's an out flat int is the way I'm reading it. So we say flat here. Let's just see if it complains. Yeah, it also needs to say on the fragment that the integer here is flat as well. So we are going to clean and recompile that. Just switch over, prepare, and it's linked. Try loading. Lots of stuff that isn't good. Storage qualifiers have to be after interpolation qualifiers. So the way I'm reading that is that it wants flat even further forward, so it's a flat input. That kind of reads naturally, and a flat output. Let's try again. There we go. We've managed to link. We switch over and reload. So, vertex attribute 3 requires data of type int but is being supplied with type float.